Virgin Galactic is moving closer to its goal of providing suborbital space flights for tourists. The Richard Branson-founded company has released a conceptualization of what the cabin of its first Spaceship Two vehicle, VSS Unity, will look like. Space enthusiasts can download a free augmented reality mobile app to experience it for themselves. The cabin has been created to integrate seamlessly with every other aspect of the Virgin Galactic astronaut journey, as well as being a design centerpiece in its own right. Each passenger is issued an individually sized reclining seat for G-force management and float zone volume. Automated mood lighting harmonizes with each flight phase. Personal seatback screens connect astronauts to live flight data, while the cabin architecture supports effortless movement in weightlessness. Soft surfaces and elements become intuitive hand and footholds. And most importantly, there are 12 cabin windows through which astronauts can gaze down at Earth. The windows have soft, extended edges, allowing astronauts to perfectly position themselves for 360 degrees of awe-inspiring views. Chief Astronaut Instructor Beth Moses has had the opportunity to trial this unique experience.
My name is Beth Moses, and I'm the Chief Astronaut Instructor and a flown astronaut at Virgin Galactic. I was the first person to fly in the customer cabin of Spaceship Two as an engineer and an instructor testing the cabin. And that flight showed that the cabin was ready for human occupancy. I flew in a prototype cabin with research payloads, tested a lot of things. It tested a few ways to get in and out of the seat. It tested ways to improve the seat interfaces. It tested translation aids, handling aids, how you move about the cabin. Very fundamentally, it looked at how the cabin moves about you when you are floating and weightless. What aspects of the experience stand out, perhaps in ways that we didn't anticipate before a human could go calibrate that. So now I've rolled that all into training and into the cabin design so that it is perfectly tuned, elegant, easy, safe, wonderful. It was already freaking remarkable, and now it's even more so for all of our future customers. So the moment where we strapped in and the hatch was closed and the wheels started to roll sticks with me as a moment of sort of personal gravitas, like I am about to do the most important job of my life, and I am going to do it well. The rocket motor is not exceptionally loud. You are under 3G, you are rocketing into space. It is the rocket ride of your life. And then the rocket motor cut off. You can see the Earth outside all the windows. It is super, super bright, very high definition. It just engulfed me. Space is deep, deep, deep black, and it looks endless. And probably the next standout moment, I did the first half of my test, and then I purposely joined the pilots near the cockpit for apogee. And that's probably the standout moment of my life. Floating, free, in the ship, and the ship came to a stop above Earth, and it felt endless. The cabin interior supports savoring the view of Earth from space in every way possible. It both facilitates your movement about the cabin, so you can get to any window or next to any person that you'd like to, while simultaneously not distracting you from the view that you're looking at. The cabin interior will be successful when the space flight and the view of Earth from space is the star of the show, and the cabin is almost an invisible but perfect supporting act.
But it's not cheap to take a ride on the VSS Unity. For $250,000, you get a 90-minute flight that takes you high enough to experience weightlessness and see the Earth from space. By surpassing an altitude of 80 kilometers, Virgin Galactic space tourists will also receive official astronaut status. Amazon's Jeff Bezos is another entrepreneur who has his sights set on space. The billionaire founded commercial spaceflight company Blue Origin in 2000 with the aim of making access to space cheaper and more reliable through reusable launch vehicles. Blue Origin envisages a future where millions of people live and work in space, tapping its unlimited resources and energy. Its rockets transport payloads for organizations such as NASA, who have used the launches to further research for their upcoming moon mission. At a cost of just $8,000 a payload, the company has even flown experiments for school students. A second-grade class in Indiana was able to demonstrate that fireflies can light up in zero gravity. Blue Origin's New Glenn orbital vehicle will take tourists into space, where they will experience weightlessness and new views of our planet, just like the Virgin Galactic astronauts. The cost is expected to be about the same. Blue Origin was recently awarded a NASA contract to develop an integrated human landing system as part of the Artemis program to return humans to the moon. The third big player in the commercial space industry is Spacex, the company founded by Tesla's Elon Musk in 2002. Its original aim was to reduce the cost of space transportation to enable colonization of Mars. The company has since become the first private operator to successfully launch, orbit, and recover a spacecraft, and the first to send a spacecraft to the International Space Station. SpaceX's latest innovation is an interplanetary transport system known as Starship 4 to be used for crewed missions to Mars. Expected to be completed by the early 2020s, Starship will be the biggest rocket ever made. The system will comprise a fully reusable, two-stage-to-orbit, super heavy-lift launch vehicle, which requires considerable testing due to its innovative design. The heavy launch vehicle is just required for the initial launch, as only Earth has the deep gravity well that requires such a powerful booster rocket. Once the vehicles escape Earth's gravitational force, Super Heavy detaches from Starship, leaving the lighter spacecraft in parking orbit. The booster then flies itself back to Earth, landing on its original launch mount, ready to be prepared for its next expedition. When you put a human being in a spacesuit, sometimes the impossible is possible. Since 1965, NASA has conducted hundreds of EVAs, short for extravehicular activity.
So when I think of EVA, I think of the symbolism of a fellow human being existing for even just a short period of time, alone and separated from nearly everything else. And I think of that symbol of that single person representing our species and representing our voyage of exploration.
Before exploration can take place, before a human being can step outside the spacecraft, another mission must be accomplished: the creation of the spacesuit. Throughout the history of EVA, NASA has sought to build the best spacesuit and tools to match the job required for the mission. For its suit engineers, this means designing, testing, and redesigning to get it right. During the Gemini program, designers were faced with the challenge to create the first US spacesuits. Suits that would allow the astronauts to work outside the spacecraft in low Earth orbit. Building on that experience, new suits were developed for the Apollo missions. This time, astronauts needed to walk on the moon while carrying their own life support on their backs. With planetary surface exploration as the objective, the suit had to bend and move to allow tool use and protect the human. During the shuttle years, NASA redefined what could be done with the EVA suits and tools. The same shuttle spacesuit is on the space station today. It allows astronauts to maintain and repair their home in space. But what about future missions? What kind of suit will we need for walking on an interplanetary surface? Floating in microgravity, or both? NASA is already investigating the next generation of spacesuits, working on a range of prototypes to prepare astronauts for the journeys ahead. The Z2 is one of those prototypes. Its sleek design looks different from any other spacesuit NASA previously built.
We were able to take some artistic license on this prototype spacesuit and have some fun with it and engage folks out around the country for what they would like to see in a spacesuit. We worked with Philadelphia University to do the initial layouts of the suit, and then we have some in-house fashion designers that also help build our spacesuits, and they were able to bring their experiences to it and evolve that cover layer to make it even better than what we started.
The Z2 isn't just fashion-forward on the outside. It's also technologically advanced on the inside.
To be a planetary spacesuit, some of the special features on the Z2 are boots specifically designed for walking and for keeping your foot integrated into the boot well, like a good hiking boot. It also has a lot of lower torso mobility that allows you to walk naturally so that you can go uphill, downhill, into craters, pick up a rock, as a geologist would want to do on a planetary surface.
Like any prototype, NASA hopes to learn a lot from the Z2 as it continues to improve and develop spacesuits.
Prototypes are really important for spacesuit development because you can only do so much in the modeling and analysis world. You really don't know how well the suit works until you integrate it with a person. You get the feedback that a person can give you. You have them walk around, you have them try different tasks. That's how we really know that we've done a good job designing a spacesuit.
Another suit in the works is the Prototype Exploration Suit, or PXS. This suit can be used for EVAs in microgravity, or it can be further modified for walking on planets. As with all future spacesuits, NASA is wanting to see better mobility, better visibility, and better control and communication.
So one of my main responsibilities on this spacesuit is the suit control assembly, and that's the box that sits right here on the front of the suit. And it allows the crew member to control their life support components, such as their cooling and their pressure, and it also controls a lot of the electronics, such as the radio and the volume, and they can see some of the data that's coming back and forth from the suit computer to that display. So one of the great things about this job is that after designing the box, I'm able to get into the suit, since it's one of the smaller sizes, and we can actually see what the limitations are with my own hands and eyes, and not just hear that secondhand from another test subject that would be looking at the same data. And then to take that back and then to go build the next prototype and incorporate the changes that need to be made so that it works better the next time.
It's not just spacesuits that are key to a successful EVA. Astronaut training is also vital, especially when the mission is difficult. European Space Agency astronaut Luca Parmitano recently undertook a spacewalk at the International Space Station to repair the alpha-magnetic spectrometer. The AMS-02 is a particle physics experiment mounted to the outside of the space station. 3 of its 4 cooling pumps needed replacing.
It's a combination of things that makes this EVA so challenging. You have certainly an access problem. AMS is in a remote area without handles or locations to hold on to because it was not made to be repaired EVA.
0 and liftoff.
AMS was carried to the space station on the final flight of Space Shuttle Endeavour and installed using the shuttle's robotic arm. As the most sophisticated particle detector ever sent into space, AMS allows scientists to find dark matter. To date, it has detected over 100 billion cosmic particles, greatly enhancing our knowledge of the universe. When the decision was made to extend the instrument's life, a series of specialized tools and novel spacewalk techniques had to be developed. At the Johnson Space Center in Houston, experienced spacewalker Luca Parmitano played a key role in this process.
I've been lucky enough to have been part of the development team from the beginning, initially just as a consultant and then actually getting closer to the team in using me as a test subject for some of the tools. They've been incredibly receptive to our suggestions and responding to our ideas. It's been exciting.
Working inside a spacesuit in microgravity poses many challenges. Luca and his NASA colleague Andrew Morgan trained on specialized equipment to recreate working conditions in orbit, such as the Argos system, which effectively removes gravitational force to create a simulated EVA environment. Numerous underwater sessions in NASA's Neutral Buoyancy Lab gave Luca and Andrew a working knowledge of the space station's exterior, rehearsing fully suited operations on a mock-up of AMS.
We're going to perform what could be considered open heart surgery on this amazing experiment. We're going to cut tubes and then fuse them with other tubes that we're going to bring from Earth and install a completely new pump to help the refrigeration work, keeping the magnet cold so that the alpha magnetic spectrometer can work.
Drawing on their extensive training and experience, Luca and Andrew have since successfully undertaken a challenging series of spacewalks to restore the alpha magnetic spectrometer. Their mission included cutting and splicing 8 cooling tubes, connecting them to the new system, and reconnecting power and data cables. It was the first time that astronauts had cut and reconnected cooling lines in orbit. They also had to identify and repair a leaky feeder tube. As the astronauts worked on their tasks, they were closely watched by Mission Control in Houston. When undertaking strenuous work, they used more oxygen, so their spacesuits were carefully monitored to see how they were performing. At 5 hours and 2 minutes into their third spacewalk, Luca broke the record for accumulated time outside the space station by a European astronaut. It was the 227th spacewalk for the International Space Station. Thanks to their efforts, the AMS has now been fully restored, allowing it to explore our universe for many more years to come. 50 years after putting the first man on the moon, NASA is planning to return.
We have a bold vision to go, and we do so knowing that space exploration has improved the human condition in countless ways. And it is the partnerships over the last 50 years that have ensured a steady progress in the science, technology, exploration, and discovery for the benefit of all. With America's new directive to put humans on the moon in 2024, NASA is leading the development of exploration capabilities, and we are building a coalition of nations that can help us get to the moon quickly and sustainably together.
With the help of partners such as other space agencies and private space companies, NASA is working to an ambitious timeline. Next-generation space technology is being used to build advanced spacecraft to take crew to the moon and ultimately to Mars.
For the test one.
Accelerating the timeline means a lot more focus, means a lot more dedication to the task, and we're up for it.
One of the key mission features is the development of the Gateway, a moon-orbiting platform that will serve as a waypoint for human capsules.
Gateway is a great step towards the future of the human being. It's a great pleasure to collaborate with NASA in that endeavor.
Gateway can be moved between orbits and will balance between the Earth and Moon's gravity. But the technology is so advanced, it requires the best scientific minds from all over the world to contribute.
NASA is one of our major cooperation partners in space exploration.
By going together to the moon, forward to the moon, whatever the time span is, the faster the better. That's something I really like.
Scientists hope the lessons learned will enable them to develop a successful mission to Mars. Between 1968 and 1972, NASA launched 9 human missions to the moon, 6 of which successfully touched down, allowing men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of both creating a long-term human presence on the Moon and preparing for a human mission to Mars. To reach the Moon, astronauts will fly in Orion, a spacecraft built in 3 parts. The crew module can house up to 4 astronauts who will live and work throughout the flight. The service module contains the life support systems for the crew and its own engine and fuel reserves. And there's a launch abort system with engines capable of pulling the crew module to safety at launch should anything go wrong. The world's most powerful rocket, when fully fueled, Orion weighs over 6 million pounds. 5.2 million of that is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, projecting the crew upwards. 2 minutes after ignition, the rocket boosters are spent and released. At 8 minutes, the 4th stage is depleted and separated. Approaching the Moon, we see a difference between the Artemis and Apollo missions. Artemis will use a revolutionary approach, pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners, including Gateway, the dedicated lunar station in orbit around the Moon. Here at this station, the astronauts can pre-stage a robust lunar lander and establish a strong communications relay. When that's complete, selected astronauts transfer to the lander and descend to the surface. They use the same lander to leave the Moon and head back to the Gateway, where they return to Orion, firing their engines once to break out of the halo orbit, and once again to sling the spacecraft around the Moon, they head back to Earth. Nearing the end of this journey, the service module is released and the crew module is oriented heat shield first. The deployed parachutes decelerating the craft to just 20 miles per hour for splashdown.
10, 9, 8.
The recent launch of the Mars 2020 Perseverance rover highlights the next chapter of Artemis, the mission to Mars.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
Oh man. That's a noise.
It might not be long before we join robots on Mars and experience the next frontier of human endeavor.
Can you feel it inside?
So, where will you fly tomorrow?